Good evening, students. Today we are going to talk about titration, and I want to explain it further because earlier on I introduced it to some point. So today I want to use this illustration to explain everything so that you get to understand how titration is carried out, what you need to do stepwise. So looking at this diagram, we have part of the apparatus that I gave in the last lesson. The burette is here and the conical flask is here. So to put things into perspective, the solution that is in the conical flask down here is the solution that you get from the pipette. Remember, I said you suck 25 cubic centimeters of one of the solutions, you transfer it to the conical flask. Then you add an indicator. That's why here I've labeled solution B plus an indicator. Solution B can be an acid or a base. And then in the burette, we have solution A. If this one is a base, then definitely this one is going to be the acid. Now, get to understand this. Whatever that you place in the burette is called the titrant. Whatever that you place in the burette is called the titrant. So what are you going to do here? Remember, solution B is 25 cubic centimeters. So you are going to open this tap and allow this solution to run dropwise into the conical flask, while you gently shake this conical flask to allow the reaction between solution A and solution B to take place. Be careful such that you wait for the indicator to change color sharply. The moment it changes color is when you will close the tap and read the volume of the titrant that has been used. This volume is going to run from 0 downwards, maybe up to 15 cubic centimeters, up to 20 cubic centimeters, 30 cubic centimeters, depending on the concentration of the solution and this one. So let us define some few terminologies here before we get to understand what really happens there. What you need to know under titration is concentration and molarity. Concentration is simply means amount of solute in a given volume of water. Water in this case is referred to as solid. For example, let the amount of solute be 25 or let's say 22 grams of sodium hydroxide. This one is your solute. And then you have 250 cubic centimeters of water. This one is your solvent. We know very well that when you add solute to solvent, you end up getting a solution. So the result of this and this is that the concentration will be 22 grams of sodium hydroxide per 250 cubic centimeters. Is the concentration of this solution. Now, concentration can be in terms of grams, volume of solvent that has been used, mass per volume of solution that has been used. This volume can be any volume below 1 liter or exactly 1 liter. So, other expressions of concentration include grams per liter, or grams per cubic decimeter. That means if 22 cubic centimeters, 22 grams of sodium hydroxide are in 250 cubic centimeters, what about 1000 cubic centimeters?